there are, oops, why is it doing that? I don't know. Hold on. 5 special or angle relationships you need to know. You need to know the name, of course, but also the property or its relationship, and we're going to draw examples to each different types so that you can read the relationship correctly. So for vertical angles, these are 2 angles that are across from each other. Okay. Maybe you want to put from each other. And this is very important. They're always congruent. Always congruent. So I'm going to first show vertical angles by indicating 2 lines that are intersecting, because that's the way they are formed. All right, so I'm going to do 2 diagonal lines. I do want you to draw this example. We're going to do lines, okay, named by point. So this first line is EC, okay, line EC. So you need to add the points E and C towards the end of the line, and then it's going to intersect line AD, excuse me. I don't know why it's doing that. Let me see if I can fix that. There, no. Line AD, and it intersects at point B. We got to still review the 3 different ways you can name angles, okay? But we need to help you recognize vertical angles, because these are always the angles you should try to identify first, because they're congruent. So one of our sets of vertical angles is basically looking at, and I meant to do that in blue, sorry, is looking at the left to right. The left to right angles, like are across from each other, left across to right. So which angle, we need to name the angle that is on the left. That would be vertical to the angle on the right. Yeah, I'm going to put an arc. What Connor just told us, he's correct. So put the angle symbol, and then we do ABE. That angle, because it's vertical to the angle to the right, is going to be congruent. Vertical angles are always congruent. So I'm just showing the congruent symbol. And now we need to name the angle it's vertical to, the angle on the right. 3 letters. Angle CBD. Yes. And I notice I'm going to put an arc right there. Okay. So we need to, that is a C, sorry. We need to be able to identify them, see them with intersecting lines. We'll be able to show the congruency statement by naming them. We can name with 3 points. Make sure the middle point is the vertex. The middle letter is the vertex. Okay, so we can go left to right, or we can go top to bottom. Okay, or we can go top to bottom. So what is the name of the angle at the top with our intersecting lines? To the top, say that again. ABD. No, ABD is the line. ABD is the line right here. No, the ABs. Okay, so angle ABC is going to be congruent to which angle? EBD. Yeah, EBD. Okay, so I can show that also with the marking. Notice I'm now going to be 2 arcs and then 2 arcs. Okay, but know that they have to be across from each other. So I do want you to identify that relationship and know that they're always congruent. When finding angle measures or missing angles, you should always start with vertical. Okay. All right, I'm going counterclockwise because this will kind of address all the ones we've done in class already. So our adjacent angles, These are two angles that are next to each other. So next to is that help you to see that relationship. And they share a common side, and we need to add on here and a common vertex. This is gonna get on my nerves. Why is this showing up? I don't understand. We'll figure that out. Okay. All right, so here we're just gonna draw our angles using adjacent, using an acute angle in our representation, and we're going to use another way of naming angles with numbers. So start off with drawing an acute angle like such, and make sure you have your little vertex to show that it's okay. Then you're going to need to, so right off the bat, this will be our vertex in our angle will be the common vertex. It's going to be shared. This is when we did CV to indicate it, okay, if it was a common vertex. Now, we're going to draw some adjacent angles, so that means I need to now add a ray from this common vertex extending to the interior. So now draw a ray from your common vertex extending in the interior. So we are going to name these two angles that are going to be adjacent. Angle 1, and we could put one arc to show that measure in between the two rays will be angle 1. And we're going to do 2 arcs and put angle 2. Angle 1 and angle 2 are adjacent because not only do they have a common vertex, but if I draw an arrow pointing to this part here, we have a common, let me change my font, a common side. This ray down the, kind of like in the middle or in the interior, is your common side. So if I have adjacent angles, the only thing we can really use when we have adjacent angles is our angle addition postulate. So I'm just going to add a little note here that if they're adjacent, I think I have room right here. Angle 1 plus angle 2 is going to equal the whole angle. Okay? When they're adjacent, you can add. All right, another angle relationship, the special pair, is complementary. And we talked about this as when you're C in complementary, I could turn that C into a 9 and get 90 degrees to help you. So the key for complementary angle, these are any two angles with a sum of 90. So sum of 90 is the key fact that you're going to apply to problem solve. Okay, so there's 2 ways we can show this. All right, I can show it using adjacent angles. So I'm going to start off with drawing a pair of adjacent angles. I'm going to number them 1 and 2. So start with that example because we're going to do 2 representations. Okay, right now I'm showing adjacent. What needs to be added for it to show complementary as well? The box. Yes, so you need to add your box to indicate they are complementary. The box indicates 90 degrees, so now I can say angle 1 plus angle 2 equals 90. The sum of those 2 adjacent angles are 90. Now, complementaries just have to have a sum of 90. They don't have to be adjacent. So if we're going to do this, I'm going to draw an angle like such. And I'm going to put 30 in the interior to indicate that angle is 30 degrees. So If this angle is 30, what would be the measure of its complement?
30.
No. 60. How do we know it's 60?
30 plus 60 is 50.
Yeah, it has to be 30 plus 60 equals 90. So my complement just needs to be an angle that we have 60 degrees in the interior for. It doesn't have to be the scale, it just has to have the complement measurement. So I do want you to make sure you understand that they do not have to be adjacent, they just have to have a sum of 90. Okay, so the complement is the measure that makes it a sum of 90. So if I have an angle that's 80 degrees, what is its complement? 10. Okay, if I have an angle that's 45 degrees, what is its complement?
35.
Try again.
45.
45. Okay. All right. Then make sure you understand supplementary angles. Those are any two angles whose sum is 180. Okay. So I am going to show, well, I won't have to show two representations. But another way to think of it is if I have a S, the S in supplementary, we can turn into an 8 and make 180 degrees. Okay. Remember, just they have to have a sum, so they do not have to be adjacent. There is a special type of supplementary angles that are adjacent. So if I have, I'm just going to sketch an acute angle, and I'm going to make this angle 40. So draw an acute angle and put the measure 40 in the interior. If I have supplementary angles, what would be the supplement to this angle? It would be 140. So I just need to kind of draw like an obtuse angle and put 140 in the interior. So I'm showing that 40 plus 140 equals 180. I have to show that they have a sum of 180 to be supplementary. And then the last pair that you're kind of familiar with because they're supplementary, it's just linear pair. Okay, sometimes I put, for linear pair, I put LP. Okay, sometimes I use that abbreviation, LP for linear pair. Does it look good? LP. Okay. Now, this is just two angles that are adjacent and supplementary. Okay, they're adjacent and supplementary. So it's just a special type of supplementary angles because now they're adjacent as well. And the thing that you need to remember is they will form a straight line. So we're going to do multiple representations of that, how that can occur. Yeah, Eddie's there. All right, one of the ways is we can start off with just a horizontal line. So start off with just a horizontal line. To make this a straight angle, we're going to add a point on the line. What's the degrees of this line or this angle? 180. So right now we know it has a degree of 180. So to show linear pair, I just need to extend from this point, make this my common point, and make one angle acute and one angle obtuse. Or I can make them both congruent, but I need to show two angles. So I can have 1 and 2. So here I'm showing angle 1 plus angle 2 would still be 180, a sum of 180. So I can do a horizontal line, I can have a vertical line. Okay. Again, the degrees of this angle is going to be 180. So all I need to do is extend another ray to create one acute and one obtuse. Okay. The most common way that this happens is with intersecting lines. So I can have two lines intersecting like such. Put my point of intersection. When I have two lines intersecting, now I have a total of 1, 2, 3, 4 angles. Okay. All right, there's more than one answer on here, so we're going to list 3 possible ways to identify linear pairs. Which 2 angle numbers, okay, we're going to use the numbers, would make up a linear pair?
1 and 2.
I could say 1 and 2, so I would write angle 1 plus angle 2 equals 180. That is correct. Anyone see another pair?
3,
Say that again.
4 and 2.
Yes. Angle 4 plus angle 3 equals 180. Let's do one more. That's not like the 2 that we have listed. 4 and 1. So I can still say angle 4 but not add it to angle 1 and it equals 180. So there are more than one combination at times. Okay? All right, you're going to need this sheet to help you with some practicing of finding missed angles. So let's go ahead and get it into our spiral, and then we're going to do the practice next.